Hello, Danny Crane, and welcome to my beginner's guide to TIS-100. This video is going to be as spoiler-free as I can make it. It's aimed at the people who just picked up the game and want to know what's going on. Maybe you read the manual, but you're still unsure of what to do or how to do it. So let's get started with basically what is TIS-100. Well, it's a fictional computer that you found in a yard sale or something like that, and when you turn it on, you find all of these different segments have been damaged. They lost their programs, and each one of these tests for a different thing. And it's your job to repair the computer by rewriting the programs for each one of these. So how do you go about doing that? Well, basically what you're doing is you're moving around blocks of numbers. In most tests, you're going to have an input and an output, and you have to do stuff with the input numbers and then output whatever number the test is testing for. So in this one, all we're doing is we're getting an input from input X, and we're writing that same value to the output. And then we have also an A input and an A output that we have to do the same thing with. So like I said, you're moving around blocks of numbers. When you look at the screen here, you'll see all these different blocks arranged out, and these are called nodes. Most of them are gray in this test, and these are the ones where you can actually write different codes, different programs, to be able to move those blocks of numbers around. You'll also see these red blocks that say communication failure. These are ones you don't have access to. You can't move data through them. You can't get data from them. Some of them have a debug button. When we click on those, we get a little bit of flavor text, a little bit of story. Each one of the levels I've encountered has at least one of these communication failures in them, and you just have to work around them to make the program work. You'll also notice that there are these arrows in between all the blocks, and those are the paths that you can send those data blocks, those numbers that you're working with, between the nodes. So you can see I can send data back and forth between these two. I can try to send it into the failed block here, but it won't do anything. Now, in this particular test, all we're doing is we're moving numbers. So you can see up here, it's using the move command, MOV. Whenever you write that, and the cursor, when the program gets to that point, it's going to look at whatever you wrote first. So if you wrote a direction, say like in this one, it says move up, this block is going to look at the up arrow for a number. And once it sees one, it's going to move it to the down arrow. So it's going to move it down here, and the next one does the same and the same until it goes to the output. So you can do the same thing over here. So if we do move up, we can't send it down because it'll hit the failed block. So instead what we want to do is send it over to the left right here. So if we write left like that, it'll look up here for a number. When the input gives us a number, it's going to send it to this block over here. Now on this one, we would write move right because we want it to look at the right arrow over here, and then it's just going to move it down. And then this one we can do match what's on the other side, so we'll do move up to the down arrow, and then this one we're going to look at the up arrow and move it to the right. And then finally we've got move left down. Now when you use the move command, it's going to stop this block until the receiving block takes it. So that can cause some issues further on down the road for you in some of the more complicated tests. But you can see if I step through it here, we get a 68 and we get a 51, which are the two values that it says it's going to give us here. This first block, it's going to look up here and send it down here. And then same thing over here, it took that value and moved it to the left arrow. Now this one's looking over here for a number, and it waits until there's a number there, and then it moves it down, and then so on and so on. And we can just go ahead and finish that out by hitting the run test. Now when you run it, it actually runs 4 tests, 4 strings of numbers. The first 3, there we go. The first 3 are going to be the same every time. So test number 1 will have the same string of numbers. Test number 2 will have a new string of numbers. Test 3 will, again, new set of numbers, but each time they'll be the same. The 4th test is a random test where it gives you random numbers the entire time. Now that's important on certain codes that you might write that won't always work when you get numbers in a certain order. Doesn't affect too many tests. Usually you can write your programs pretty easily. Now, when you finish the test, if you pass it, it will give you a diagnostic report here, and it'll show you how many cycles it took to complete the program, and that's basically each tick of the clock. So it took 83 ticks in the slowest version of the test to be able to pass it. I used 8 nodes, 8 of these blocks to complete the test, and I had 8 lines of code. Each one of those boxes only had 1 line of code apiece, so I have 8 instructions. So now more on to the different instructions you can use. I'll go into the sandbox here because it doesn't have any spoilers in it, and I wrote on the side all the different commands that you will encounter in the game. And I wrote these in the same order that they're in the manual, so if you want to read along with that, you can. To get the manual, you just hit the escape button, and there's the view, the TIS manual. It pulls up a little PDF for you. They encourage you to print it out, but I don't have a printer, so I didn't bother with that. Now, the first thing that comes up in the instructions is the ACC. That stands for the accumulator. That can be a target for your move command or a target for your jump and add commands when we start getting into the logic. And what that actually is a place where you can hold a block of data, basically. It's right up here in each one of the nodes. It shows you the current accumulated value. So you can do things like move ACC down, for example, and that'll make the move command to take whatever number's here and move it to the down arrow. You can also have it be the target, so you could say move the up value to the accumulator instead, so it'll take whatever's coming from the up arrow and move it into the accumulator. The backup, BAK, is kind of the same thing. It's another place where you can store numbers, but the difference with this one is you can't target it directly. What you have to do is send it numbers from the accumulator, and when you want to get numbers back from it, you have to send that number back to the accumulator, and I'll talk about that later with the swap and save command. Nil is the next thing. Nil basically means 0. Whenever you want to write a 0, you can write nil instead, or if you want to clear something out, you can use the nil command also. So as an example, if I were to write move 10 to the right here, and then say move 5 to the right also, and let's say I only wanted the first number of those. Sometimes you'll do a test where you're going to have 2 numbers come in, and depending on where the test is running, you might only want the first one, or you might only want the second one. So what you can do, let's say we moved the left value to the accumulator, so it'll save that first number in the accumulator, and we want to get rid of the 5, but we want to free this node up from delivering it. So what we can write instead is move left to nil, and what that'll do, it'll take the 10, put in the accumulator, and now it's getting a 5, and when it does the nil command, it makes it disappear. It just moves the left value to nowhere. So it clears up that arrow and lets the node that was sending that number move on. You could also do something like move nil to the accumulator, and when I do that instead, you'll see we get that 10, and then it's going to move nil, which is 0 in this example, and clear out the accumulator for us. So that's how that works. Now next up is the directions commands. You have left, up, right, up, and down. We already kind of discussed those. That's the directions that it would look for or send things to with those arrows. But there's also a couple other commands. There's the any command. So let's say, for example, we had this one here, and we were going to get numbers from both this node and this node, and we just wanted to take whichever one came first. So if we did move any to the accumulator, and then let's say we did move 10 down, and then over here we could do something like move 5 down. We'll do, rather than that, let's do it up here instead. We'll do move 5 down, and then we're going to move up to the right. So what's going to happen here is this block, when it first hits that line, it's going to look at all of the arrows going into it, and it's going to take the first number that comes into it. So on the second tick, you see we get a 10 on this arrow, nothing on the others, so it's going to move that 10 into the accumulator. Now it's going to do it again, and it looks and we see a 5. So it moves the 5 to the accumulator, and then we're going to get a 10. So that way you don't have to write a specific direction to get a number. You can just let this node that you write it in accept whatever comes into it first. last is kind of similar. It only works if you've already done an any command. When you do this, I'll step through it again here. So you see the first number we get is a 10 from the up direction, and when we move that in, the last updates. So you see most of these say no answer on them, but this one, the last time we used any, we got a number from the up. And so if I were to say at this point move last to the accumulator, now instead, when it hits that, it's going to look only in the direction that we looked at last for any. So you see we got a 5 and it ignored that. Now we have a 10 in the up and it's going to take it. Now it's going to do any again. It's going to see the 5 and now it's updated again and we see last is now left instead. So it's going to ignore this until there's another 5. And so that's how that works. Next up is the comments. The comments are what you see on the left side of the screen here. Anytime you have the hashtag mark right in front of anything you write, you're basically telling the computer to ignore those. Those are places where you can write reminders to yourself on what different things mean or different things are. Just a handy little way to kind of keep everything organized. Labels. Labels are used with the jump commands primarily. They are basically bookmarks that you can use to have your code reference when you want it to do something. All labels are followed by the colon sign like this, and labels can either be a letter like A, for example. You got to have the colon right up next to it. You could change that to a full word, like if we did start and then have the colon, it will consider that a label. And I'll get more into how you use labels once we get down to the jump commands, because that's really where they come into play. The Nop command. Nop basically makes the computer add nothing to the accumulator. So it takes up a clock tick. It makes your cycle go a little bit longer, but you can use it for timing different things. So if I were to say move 10 to the accumulator and then write nope, and then say move 5 to the accumulator. Just like that, I can step through it. You'll see the first tick, move 10. This tick, it does nothing, and then it's going to move 5 into the accumulator, and then so on. And that's how that works. I haven't found a use for that yet in any of the codes that I've written, but I'm sure there's a reason, a good reason to use it. The move command we pretty much already covered completely. You've got the move, and then you have set a target, be it one of the directions. You could set it to last or any. You can also set it to be the accumulator or a number that you write yourself. And then you set a direction that you want to send it to. Whether you want to send it to any one of these or the accumulator, you can send it there. The swap command is a little bit different. That's where we start getting into the backup values. So let's say in this one I have move 10 to the accumulator, and then I were to write swap. When it hits that line, what it's going to do is it's going to swap the values that are in the ACC and the backup. So in this example, we'll step through it. We get 10 in the accumulator, we do swap, and then we get 10 down in the backup. So that's one way to put numbers into the backup, and that's the only way to get numbers out of the backup too. So if I were to say do swap again, just as an example, it'll swap it down and then swaps it back. So that's useful in certain ones where you don't want to send the number to a different block. You want to keep it in here, but you don't want to change the number if you start doing any math to it. Now, the other way you can get numbers into the backup is with the save command. So if I wrote save instead, what it's going to do is it's going to get that accumulated value up to 10 because of the first line, and then it's going to save that. So it's not going to flip-flop these. It's just going to send 10 into the backup as well, or whatever you happen to have in the accumulator. That's basically it for that. Next up is the math commands. So we have add. Add, basically, when you write add, it's going to add whatever follows into the accumulator. So if I were to say write add 10 right here, when it hits that line of code, it's going to add 10 to the accumulator. And then when it hits it again and again, it just keeps adding to it. Now, it doesn't have to be a number. It could also be a direction. So if I were to say add left right here, and let's say we'll move 2 to the right here, and we step through it, this will send 2 to this arrow. This one is looking that direction, and whatever comes from the left, it's going to add to the accumulator, and so on. So you can set it up that way. You can also set it up to be the accumulator itself. So now I can't add the accumulator to 0 because that won't work, but let's say we'll just do move the left to the accumulator, and we can step through it here. So we'll get a 2 into the accumulator, then it's going to add whatever that is to itself, and we get a 4. That's pretty much it for the add command. Fairly simple and straightforward. The sub is basically the same thing. So if I were to sub the accumulated value, we get our 2, and then it's going to subtract it from itself. I could also do a number instead, so I could subtract 1. So you see we get our 2, turns it into a 1. Well, basically that's it for that one there. The last one is the negate command, NEG. So if we were to move the left to the accumulator, and then we make it a negative number by doing NEG, what will happen is we get that value in, and then whatever's in the accumulator, it's going to make it, if it's a positive, it's going to turn into a negative, just like that. If it was a negative number, it'll make it a positive. So if I were to say write another one of these right here, we get our 2, makes it a negative, and then it can make it back into a positive. So that has its uses in certain tests where you always want to have a positive or a negative number coming out of a node. You can use the negate command. Last up are the jumps. The jumps are where you start doing your actual kind of logic tests, basically. These are tests that let you skip steps in your code. Normally when you write a code, it's going to step through each one of the lines one at a time until it hits the end, and then it'll jump back up to the start. Well, with the jump command, you can skip things. And that's where labels come in. So let's say I wrote a code here that said started with start, and we'll just say move 10 to the accumulator, and then we're going to do jump to the start, just like that. When it hits the jump command, it's going to jump to whatever label you write afterwards. And you can see that if I do, say, move 1 to the accumulator down here and actually run through it, we'll get our 10 into the accumulator, and when it hits the jump, it's going to jump right to the start one. Now it can jump either backwards or forwards, wherever you want. It just jumps to the label. So if I did another label here called test, and let's say move 2 to the accumulator, just like that, and let's change the location of this. Jump to the test instead. You'll see when I step through it, it sees the jump to the test and jumps right down to it. That's pretty much all there is to know about the regular jump command. The next ones start getting into your logic. So the first one is this one here, JEZ. JEZ stands for jump if it equals 0. So in this test, it looks at the accumulated value, and if that number is equal to 0, it will jump to the target location. If it doesn't equal 0, it'll just continue on to the next line. So you see in this test here, we start off with 10, it checks it, and because it didn't equal 0, it moved on to the next one, where it moved 1 to the accumulator, and moved 2 to the accumulator, and so on. Now if the test is positive, so for example, let's just get rid of this completely, and we can step through it now. Our accumulated value is 0. This is true, so it's going to jump down to test. The next one is jump if it's not 0. So same idea. The difference is it will only jump if the number is not a 0. So if it's a negative number or a positive number, it will jump. So in this example, you'll see it doesn't jump. But if we were to put back our move 10 to the accumulator up here and then press start, it sees the 10 and jumps down. The next one is jump if it's greater than 0. And along the same lines, it just looks at this number again, and if the accumulated value is a 1 or higher, it's going to jump to the target location. If it does not equal 1 or greater, if it's a 0 or a negative number, it's just going to ignore that and move to the next line. JLZ stands for jump if it's less than 0. And that's the same thing, but now it's looking for a negative number. So if it sees -1 or less, it will jump. If it does not see that, if it sees a 0 or a positive number, it'll just ignore it. The last one is JRO. Now this one is quite a bit different. This one doesn't use labels. Instead, what you do is you write either a number after it, so I could write, say, 2, like this on there. I could do a negative number, like -1 as another example, or I could do one of the directions that you would normally get a number from. So I could do left, right, up, down, any or last if you had any command in your code before, or I can target the accumulated value. And what it does, I'll show you right here. I'll just make it do 2. It looks at that number and it jumps forward or backwards in your code that many lines. So if I step through this here, when it hits JRO2, it's going to go down 2 lines to this one. If I did a negative number, such as -1, and then step through it, when it hits that, it jumps up 1 or however many you write in the code. If you write a number that is higher than the number of lines that you have in that node, it will jump to the very last code. So if I were to say jump to 20, for example, well, this code doesn't really show it off too well, but you'll see it jumps to the very last command. If I were to do a negative number that was higher than the number of lines above it, it would jump to the very top. It doesn't loop back around, so you don't have to worry about that. Now, one neat thing about this is you can do a direction instead. So if I were to do JRO up, and let's say we'll move 2 down right here, when I step through it, it looks up, sees a 2, and will jump 2 lines of code. So you can have this node do different things based on what is sent to it from other blocks, other nodes. That pretty much covers the basics there. I hope this helps. Didn't cover everything. One thing I didn't cover is the image console. It's kind of like a basic paint program in the game. And I also didn't cover any of the stack memory nodes. You don't encounter these till much later in the game. They basically, you can send blocks of data to it, and you can get blocks of data out of it, and it'll save quite a few in the order that you send to them. So, but like I said, you don't encounter those till actually basically right here, the signal sequence reverser. So by that time, you'll have a pretty good grasp of what's going on. They do talk about those in the manual, so you can take a look at those, and I might do a video on those later on. But until next time, Danny Crane.